We're still in Goal 17 of Chapter 4, and we are looking at example number 2 to graph tangent. I want to begin by identifying A, and I see that A, the coefficient of tangent, is 1. To identify B, the coefficient of X, B is 1/2, and we use that to calculate the period. We know that the period for tangent is pi radians, so pi divided by 1/2. We keep the numerator, we switch division to multiplication and flip it. We are stretching our period to 2 pi radians. I also see that I have a value for C, so I do have a horizontal shift or a phase shift. So in order to figure out where the new asymptotes will lie, we will go back to the parent function. Remember that the parent function for tangent lies between negative pi over 2 and pi over 2. Recall that these are the asymptotes for tangent. I'll label that. So when we solve for x, by placing all horizontal changes between these two asymptotes, when we solve for x, that will give us the asymptotes that include the period change and the phase shift. So I'm going to begin by multiplying every term in the function by 2 in order to sweep the fraction. So when we multiply through, remember we must multiply every term by 2. Okay, and that leaves us with negative pi is less than x minus 2 pi is less than pi. And then if I add 2 pi in the middle and on both ends, we find that our new asymptotes are at pi and 3 pi. So recall that the distance between these two asymptotes should be equivalent to the period. So to check that, if I subtract 3 pi minus pi is 2 pi. So that does match my period. That's a great way to check your calculations. So let's try to sketch tangent. I know that my first asymptote will be at pi radians. My second will be at 3 pi. So this would represent 2 pi, 3 pi is located here. So I have my asymptotes. If we divide this into 4 equal parts, the midpoint of pi and 3 pi is 2 pi. And then if we mark the quarter and 3/4 marks, and then I will label my value, my positive and negative values for A on the y-axis. And to plot our points, remember that the first quarter mark, we're at the negative value for A, 0, and the positive value for A. And so now we have 1 period for tangent. To sketch a second period, if I ask you to sketch the period to the right, I would be expecting you to label your next asymptote accurately. Remember, to do that, you always add the period length to the end. And so if we were going to the right, our next asymptote would be at 5 pi. But I've run out of space here, so I'd like us to practice to the left. So since we're sketching to the left, then I will not add 2 pi to pi, but subtract it. So I'll take this and subtract 2 pi, and pi minus 2 pi is negative pi. So I know that this leftmost asymptote is at negative pi. And then we have our asymptote, midpoint, our first quarter mark at negative A and positive A. And now we have 2 periods for tangent. Let's finish up with example 3. I see that A in this case is negative 3. That tells me that I'm going to have a vertical reflection. I see that B is equal to 1. which tells me my period is not going to stretch or shrink. It's still going to be 1 pi. So in this case, if we place any horizontal changes between the asymptotes of our parent function, we can see that they are not going to move. So I will try to label negative pi over 2 and positive pi over 2 an equidistant space from 0. On the y-axis, we should have our positive a, in this case that is 3, and our negative a, negative 3. Now remember that we have a vertical reflection, so rather than tangent rising to the right, it's going to fall to the right. So at my first quarter mark, instead of negative 3 as usual, we'll be at positive 3, 0, and then negative 3. And then tangent is falling to the right. I've asked you to sketch 2 periods, so this time we'll practice sketching to the right. Remember, we will add the period length to this end point value. And if I want to get a common denominator, I know that I need to multiply my denominator by 2 and therefore my numerator by 2. So my next asymptote is 3 pi over 2. And we will be at positive 3, 0, and negative 3.